Today I'll give a talk on the topic that is machine learning application for the development and design of new materials. And this is one of the most important topic, particularly those who are doing research in the field of material science, nanotechnology, and that two particular area is very prominent right now because there will be always a need of new material. And if you see a material science engineer and or the person who is doing research in terms of various properties of the material, the characterization techniques. Now, generally, the people they go for experimental kind of work. But a very less number of people they go for mathematical modeling or use of machine learning in the field of material science or nanotechnology. So in this particular session, I will tell you how you can use the machine learning technique for the development or the design of a new material which you want to develop, right? Starting with the outline of my presentation, I'll give the brief introduction at the starting. Then I'll tell the how a traditional method for the development of new materials. Next, the general process of machine learning in the discovery of new material. Then use of machine learning in material properties prediction. Then we'll also go for different steps of basic steps of machine learning, application of machine learning. Then how we can predict the crystal structure of a material by using machine learning. Then also we can I'll tell you how we can go for a composition analysis of a new material. Then at the end I will give you one example which I had already yeah, completed that work in my PhD by using the concept of this machine learning or process parameter optimization in the field of nanotechnology. And from that I'll draw some of the summary. And okay, if you see this new material, always there will be a demand of new material day by day, right? The screening of high performance material and the modeling of quantitative structure activities, relationships, and other issues related to the structure of a new material are significantly important for the development of new technology in the relevant field. And the common use of the heat and trial method that cannot meet the current need for this new material. Because if you see that if someone is interested to develop a new material, in that case, by looking into the previous material and by changing the composition, by changing the method, it will be doing, it will take a huge time. Generally, from the statistics, if you see, generally it takes 10 to 20 years if you use a conventional method to develop a new material, right? Now, this machine learning techniques, if you use this particular concept for the exploration of new material, then definitely this thing will be very, the time consumption will be less, and the cost will be also reduced significantly. Because whenever you are going to test a material which you have developed, it needs a number of characterization. You will have to go for a number of characterization. For that, you have to you have to search for new different equipment for the characterization. It takes time, as well as you have to bear some cost for that. Okay, but whenever you solve this material problem by using the concept of machine learning, some data sets are required. Because if you give some data set to that, then only it can perform. So some data sets are needed that helps the targeted feature. Suppose what kind of properties you require for a particular material, that kind of data set is also required, and that data set is considered as the input parameter or input. At the same time, what properties you want. Suppose you want to develop a new material, new alloy, a new composite, and you want a properties like hardness, Young's modulus, wear properties, a significant, and your particular value you want. So that will be a targeted value, and that is considered as a output. Now, if you see this input and output relation, this material science, various material science, your machine learning added method, they can be defined using this input parameter and the appropriate machine learning algorithm to build a numerical predicting model for the detection of this unknown parameter like the output. Suppose the unknown parameter you want as hardness or Young's modulus, that will be the unknown parameter, right? Now, if you see a traditional process, generally, it goes through all these 7 steps, which I mentioned out here: discovery, development, optimization, system design, certification, manufacturing, and deployment. Now, in this traditional method, it takes a lot of time as well as a cost. Already, I told that it takes in general it takes 10 to 20 years to develop a new material by using a traditional method. But at the same time, if you use this concept of machine learning, then definitely that particular this duration or the time, that will be significantly reduced. Now, these are the, as Dr. Kanak had given my introduction. I am basically a experimental guy. Previously, I used to go for experiment, but yeah, I mean, last 2-3 years, I am also using some of the machine learning technique in my research. So these are the machine learning techniques, generally used in the day-to-day life, and it can, a lot of researchers from the field of material science and nanotechnology, they are frequently using such technique for the development of new materials, for the development, for finding the characteristics of the material, for finding the microstructure of the materials. Now, this is the general process of machine learning for this discovery of material. If you see this one, this machine learning system for discovering a new material, it includes 2 parts. One is your learning system, and other one is your prediction system. So what is this learning system? The learning system that performs the operation of data cleaning, feature selection, and model training on the testing. That basically this learning system that does. And similarly, if you see a prediction system, it applies the model that obtained from the learning system for component and structure prediction, by which at the end you can use different techniques like DFT. It is one of the most popular technique which is used in the field of material science and engineering. That is basically called as your density functional theory, by which you can get the new materials, so you can design a new material. Now, this fundamental framework of for the application of machine learning, material properties prediction. Now, how you can go for the prediction of the properties of a new material by using the machine learning. And this application of this machine learning material properties prediction can be divided into 2 broad categories. One is macroscopic property prediction, and other one is a microscopic property prediction. What is macroscopic? Macroscopic property means the properties like physical properties, mechanical properties. Now, if you see this research related to this macroscopic performance of a material, that basically focus on the structural activity relationship between the mechanical and physical properties with the microstructure of the material. How you can correlate the microstructure of the material with the mechanical properties. For example, if you see, just consider a steel example. What kind of microstructure are there? Whether it is a martensitic structure, whether it is a ferritic structure, now that you can correlate with the mechanical properties like hardness. If a martensitic structure will be there, then the hardness will be more. Likewise, you can correlate. So that is basically the your macroscopic structure, and it is related to the microscopic your microstructure of the material. And this macroscopic properties of that particular material, it is determined by the microscopic properties, including its structure, including its atomic and structural characteristics, such as lattice constant, such as this Miller indices. All these things are plays all these things are plays a crucial role for development of for finding the properties of the materials, right? Now, this overview of the application of machine learning in this material science. Basically, this application of machine learning in material discovery and design can be divided into 3 categories. One is property prediction, second one is material discovery, and the third one is this is your some other properties, like some other purposes are also there. By that, you can use this concept of machine learning, and you can calculate, right? Now, if you see this properties prediction, how you can go for a properties prediction in case of your this a new material which you want to develop. For that you need different kind of different kind of data set, and this data set must be a proper data set is required to to find out the properties of the materials. And along with that, whenever you will go for a discovery of material, in that case you have to give what kind of properties you want. Suppose you want a, whether you want a hard material, or you want a this is your any kind of very strengthy material. So in that case you can use this concept of machine learning, and you can fix the target, and how you can achieve the target by using which algorithm and all. And you have to make a model, and you have to check this model by validating the result with the experimental result. And all these things are very necessary for this material science point of view. And along with this your other purposes, if you see, in that case some other purposes like process optimization, finding density functionals, battery monitoring, all these in sector, this particular concept of machine learning is also used. If you see this process optimization, here this multiple linear regression and fuzzy neural network, that has been frequently used to optimize the process parameter of a particular process to develop a new material. For example, suppose you want to make a new material by adding the different alloying element or different additives. Now what will be the composition of each additive in that new material, that you can also optimize. Means whatever process parameter will be involved in that, that can be optimized by using this machine learning algorithm. Okay. Now here this one scientist, this Han ETL, they use this this multiple linear regression and this fuzzy neural network techniques to establish the model of relationship between the input parameter or process parameter with the mechanical properties of a titanium alloy, a titanium aluminum alloy basically. And some of the researchers, they also used the neurofuzzy and physically based model to predict the flow stress and the microstructure evaluation during the thermomechanical processing of aluminum alloys for achieving the reasonable agreement with the experimental data. Whenever you will make a model, whether the model will be appropriate or not, for that you have to validate that one. How will validate? For that again you have to perform the experiment, and you have to check the experimental data with the predicted value which you have got from this machine learning techniques. If it is nearly equal, or if it's same, then you can say that the model which you have formed, that is satisfied. Now similarly, this finding the density functional, that density functional actually this is basically this is density functional theory. It is considered to be one of the most popular and versatile method for the for the people, those who are doing research in material science, physics, chemistry, to develop a model model to investigate the structure of the material, or you can say the structure of atoms, molecules, or different phases within the material. Okay, so the quality of the result are crucial, depends on this density functional approximation. And using this density functional theory, the properties of many electron system that can be determined by using a function or a function of another function. And this machine learning approximation approach that uses many more inputs to achieve chemical accuracy, but require far less insight into the underlying physics. So basically this technique, it was come into existence after year 1980s at this your density functional theory. And a lot of people from the field of material science, chemistry, physics, they use this concept to develop a mathematical model to find out this structure of a atomic structure or molecular structure of a particular material. In that case, whether the how to classify the material on the basis of which category. If it is a metal, then what will be the band gap? Whether if it is a semiconductor, then what will be the band gap? If it is a ceramic, then what will be the band gap? That thing also you can analyze by using this particular concept, that is called as your density functional theory. Then next is the battery monitoring. This is also frequently used in this field, where this machine learning technique is frequently used. And battery monitoring, that refers to the continuous determination of state of battery during the operation. And it is a challenging task in battery management system, because the state of battery is affected by various internal and external condition. Means if you see a battery and the performance of the battery, that will be directly related to a lot of factor, internal and external factor. And the relationship between the various condition and the state of the battery, that makes a non-linear relation. Means you cannot, if directly predict the value by looking into the this internal external condition. And this machine learning technique, that provides a superior means of predicting battery parameters, because of its advantages of capturing the relationship between battery state and a related factor by constructing a train model. And regarding that, one scientist, Lee, he had established an fuzzy neural network model for the state of change estimation, in which the internal resistance, voltage, current of the battery are used as a primary input variable. And a lot of people, they have worked in this particular area, because of right now, due to this the application of battery in the electric car and all. So that's why a lot of research is going on in this particular area. Now, this basic concept, the basic step of machine learning in material science. If you see the various step of machine learning, various step of machine learning in material science, it has been broadly classified into three types. One is sample construction, second one is model building, and the third one is model evaluation. Now we will discuss one by one. What is model? That is your first is sample construction. The sample construction is basically in material science, the original data that are collected from the computational simulation and the experimental measurement. Because whenever you will use the technique of machine learning, in that case you need a good or stable data for that. For that you have to either go for some computational simulation, or you have to go for some experimental measurement. Now, by considering the data from the experimental measurement or from this computational simulation, directly you cannot use that data. For that you have to use a process that is called as a data cleaning. You have to use the data cleaning to perform why it is necessary, this data cleaning, because it helps to reduce the amount of calculation and efficient and it also give a efficient machine learning prediction model. If you are going for a data cleaning, then definitely you will be you're reducing the total number of calculation. At the same time, you will also get a efficient model for the prediction. And this data cleaning, in some of the paper, they have categorized the data cleaning into 4 different steps, like data sampling, abnormal value of processing, data discretization, data normalization. Likewise, it has been divided into 4 different category. Data sampling means in that case it will ensure the researchers, those who will using this particular technique, they can obtain the high performance prediction model with less number of data without compromising the accuracy of the model. Okay, so this process is called as your data sampling. Similarly, this abnormal value processing is basically used to ensure the ability and accuracy of the predicting model. Researchers, they must eliminate the abnormal value of the data which they have achieved. And similarly, the data discretization is considered as data discretization that can significantly reduce the number of possible values of continuous features, and a normalization value that will also give you a adjusted magnitude of the data to a suitable and identical level, which will be crucial for many machine learning algorithms. So this simple construction, yeah, that always plays a crucial role in, and it is one of the most important step of this machine learning in the field of material science. Now this, this is model. Your second one is your model building. So model building is basically, whatever data you have got, now you have to develop a mathematical model by considering the input data with the targeted value. Suppose, for example, if you want to develop a new material, for that case, the input data would be the composition of the material. For example, you want to develop a ferrous material. In that case, the composition of this particular material would be iron, as well as some alloying element would be there, like copper, magnesium would be there. Now, by considering this input parameter, and what will be your targeted thing, the ferrous material which you want to develop, for that case, what will be your targeted value? Means what will be its hardness, what will be its Young's modulus, what will be its wear rate? That will be your targeted value. Now, when model will be developed in between this input value with the output value, that which want to, what will that is your target, right? So one example, it is given out here. In an experiment on predicting the glass transition temperature, it is difficult to find a formula that can accurately describe the relationship between this gas transition temperature and the different factor, like the rigidness, the chain mobility, the average molecular polarizability, and the net charge. So by considering this, the predicting value, this glass transition temperature, with this four relevant factor, one mathematical model can be formed. However, this machine learning method, they can be used to develop a relationship between this conditional factor and the decision attributes based on a given example. Now, after that, this model evaluation is there. In case of model evaluation, the data-driven model should be achieved good performance not only on existing data but also on a on-scene data. Generally, we evaluate a generalization error of the model by means of calculation-based test and use the result to select the best one. Now, a lot of option would be there. Now, out of that, you have to find out the best option which is giving you the best result. And to this end, the testing data are needed to test this discriminative capability of model on a new data set. And you have to test that one by considering a new data set. And after that, you have to find out the test error from this model which you have developed, and whether the error is more, whether the error is less, that you can find out from this model evaluation. So basically, in this three step, first you have to collect the data, and data, it must be collected in a particular manner. At the same time, you have to make a model for that, and after making this model, after developing the model, you have to go for the evaluation. Means whatever model you have developed, that is up to the mark or not, you have to go for a testing by considering some data, or you have to go for testing by considering by conducting one experiment for that. So that is basically the three basic steps of a machine learning in the field of material science. Now this is a typical example. Actually, this paper, it published in 2019. This is basically a prominent IIS. It is a prominent institute in Japan. Basically, it stands for Institute of Industrial Science. It is comes under this University of Tokyo. Actually, in 2019, they developed a machine learning algorithm which can predict the properties and the structure of a unknown sample from an electron spectrum. So, and by doing this particular work, they published this one, in a very high reputed journal, that is Journal of Physics Condensed Matter. And in that case, they also evaluated the process, which may be rapidly accelerate the process of discovering and testing novel nano machines, solar cells, and other electronic device. They found this particular algorithm that will be suitable in many application. And the researchers, they choose a neural network that mimics the organization of a human brain, and the data from known material that send as an input, and a connection between the neurons are adjusted and optimize the model prediction. So basically, they develop a machine learning algorithm, and that by using this machine learning algorithm, by giving some input parameter, they will directly give you the your response parameter. Okay, so this basically this model developed in 2019 by using this IIS, the University of Tokyo. Now, by using this your concept of machine learning, one can also go for the crystal structure prediction. The reason is why we use this particular, why we will use this particular technique. The reason is that if you will not use the machine learning algorithm or machine learning techniques, you'll have to go for experiment. Again, you have to go for the different equipment to find out the structure, or you have to go for find out the composition also. You have for finding this structure of a particular of a particular sample. In that case, you have to go for this scanning electron microscope, atomic force microscope, transmission electron microscope. But by using this concept of machine learning, it can be easily predict the structural value of the material. And this crystal structure prediction that can be performed by means of this your relational analysis without any problem. And this research on this crystal structure prediction that received essentially no attention. It was before 1980. After that, it came into existence. And the in 2016, one scientist that Racuglia, he used the concept of machine learning to predict the crystal structure of a material. And when he evaluated the model, he observed that the model which he had made, it was 89% correct. So gradually the researchers are doing research, and once they will be getting a good number of data and all, so naturally day by day this success rate will also improve. This component prediction, see, if you see in general, this component prediction that can be done by using different method, like different instrument like XPS, X-ray photoelectron spectroscopy, or SEM EDS is a technique by which also you can find out the component that is available in a new material. But this machine learning concept, that can also be used for finding the component which is available in the new material. And this is widely applied in component prediction, rather than the crystal structure prediction. This particular machine learning technique nowadays, it is widely used for the component prediction rather than this crystal structure prediction. And by using that one, what will happen, the cost of this process will be reduced significantly, and also that time will also be reduced significantly. And currently the research on this machine learning based component prediction, that can be divided into two main classes. One is the recommendation of element combination from a pool of elements for a given structure, and the presentation of ionic substitutions for this discovery of new compound. And this a particular powerful machine learning tool that also can be developed for finding the novel materials by both crystal prediction and the component prediction. But there are some difficulties still exist because of the less data. Your till now we have not till now it is very tough to find out, to accumulate the number of data related to that. And one of the other reason also that this difficulties is due to the lack of availability of your this large and consistent data set, and due to the high cost of experiment and all. Because for developing a machine learning techniques and all, you need a number of data, and for that you have to perform some of the experiment. Then only you can develop a machine learning algorithm for that. So still this thing is challenging thing for the researchers, but yes, a lot of researchers, they are doing research for the development of this machine learning algorithm, and they are using for the prediction of various component of the material as well as the structure of a material. Now, here I have shown one example that is, which I had used, in my research work. And here, what I had, I had deposited one thin film coating by using a particular method, and I tried to go for the process parameter optimization by using various optimization technique. In that case, one method was considered, one machine was considered, that is considered as your CVD, chemical vapor deposition process, and different identified the different input parameter, because for any process, if you see a lot of parameters you will find. Now you have to find out which parameter has a significant on the properties of the material which is producing. Now accordingly you have to select the parameter. So in that case, we had selected three different parameters. One is the flow rate of hydrogen, and flow rate of C2H2, and the deposition temperature. Basically, this thermal CVD, what it does, it go for, it is frequently used for developing a hard coating material like titanium aluminum nitride, diamond like carbon thin film coating, silicon carbonitride, and this kind of coating has a numerous example in all sector, like in the field of mechanical engineering, in the field of biomedical engineering, in the field of your electronic engineering. This particular DLC material, the DLC thin film coating, it has a wide application in the field of biomedical engineering due to the your biocompatibility of this particular material. So three different parameters were considered, and as well as four level were also considered, means four different value were considered in this case. Now by considering this input parameter, one central composite design of experiment was considered to develop a your design of experiment. A 20 number of experiment was designed to perform the experiment by using this thermal CVD, and these are the your value of each process parameter. This S2 flow rate, C2H2 flow rate, temperature. This three were the input parameter, and two output parameter was considered. One was Young's modulus, and other one was hardness. And here in this case, if someone is interested to go for go for refitting this kind of work, in that case he can also go for some other properties like your wear rate. He can go for the coefficient of friction, by which you can develop a new mathematical model, by correlating between the input parameter, by finding the correlation between the input parameter with the output parameter. And one RSM model was considered. In that case, two different response parameter was there. One was hardness, and other one was your Young's modulus. So in the RSM model, this response parameter was one equation was developed by considering the three different input parameter, like your hydrogen flow rate, your C2H2 flow rate, and the temperature. For these two output parameter, these two equations were there. Now these are the some these are the some interaction plot, means how the how this the response parameter like hardness or Young's modulus are changing with respect to the input parameter, means which parameter, input parameter, has a highest significance for this output parameter. That also we developed in this case. And three we consider one factor constant, and we took two parameters, and we changed the parameter, and we observe these changes of this output parameter of hardness. Similarly, we also develop another model by considering the Young's modulus as the response parameter, and by changing various input parameter, how this Young's modulus is changing, that we discussed. So it was basically a RSM model where different input parameter was there, and equation was developed by considering the input parameter, and how these input parameter are changing with respect to this output parameter. That, yeah, how the output parameter is changing with respect to the input parameter, that also we observed in this interaction plot. Now, in this case, we had used the technique of genetic algorithm, but a lot of techniques are there. Anyone can use any kind of technique by considering a particular data set. By considering this data set, also you can use other techniques where you can predict the result. Here we use two different, this method. One is your single objective genetic algorithm, and we use also this multi-objective genetic algorithm. By using this single objective genetic algorithm, this three input parameter we had considered, this your hydrogen flow rate, C2H2 flow rate, and this temperature. And for this particular parameter, we we observed, we predicted one value by using genetic algorithm. So from the model which we had made, from that we got a value of this hardness as your 37.23 gigapascal, and this Young's modulus as your 335.23 gigapascal. Now same things we conducted, by considering that a particular setup, and we observed a experimental value of this 36.33 as a hardness, and this Young's modulus is 299.12. In case of this Young's modulus, some deviation was there in comparison with this GA prediction as well as this your experimental result. But however, in case of hardness, a very close value we observed, which signify that for hardness, this things is predicting a accurate result. Similarly, another experimental another this your multi-objective optimization technique was used. Multi-objective genetic algorithm was used. In that case, one set of parameter was considered, and in that the prediction of hardness and Young's modulus were compared with the experimental value, and there the prediction was it was very good in term of hardness as well as in term of your Young's modulus. So basically, this was a simple work, and I can say you that this is a particular field where this optimization and this machine learning techniques are not used frequently. And right now, some people they are using recently. But if you see the use of machine learning or use of optimization technique that frequently used for a mechanical engineer, if you see, that is frequently used in the production, in the field of production, basically in the field of machining, to optimize or to develop a meta model for the for any machining operation, like traditional and non-traditional operation. But in this particular area, this is a simple example of a particular coating, that is your diamond like carbon coating. A lot of thin film coatings are there, and lot of techniques are there. This thin film coating that can be developed by using other technique, like this was a simple APCVD, atmospheric pressure chemical vapor diffusion technique. But other than that, some other techniques are also there where we can go for the same synthesis of any kind of thin film coating, like diamond like carbon, or you can go for this titanium aluminum nitride, your silicon carbonitride coating. So for other processes, like your PECVD is a it is a kind of CVD process where such kind of work has not been done. So you can use this particular concept in that particular field. Those who are doing basically the master degree, or those who are doing PhD and all, for them it is you can choose this one as a scope of your research, and you can choose this one as a topic, because this particular thin film coating, they have a numerous application, particularly in the field of here right now a lot of people they are using this coating in the development of solar cell. So also, other than this CVD, some other processes are there, like physical vapor deposition technique, where different methods are there. You can use this concept of machine learning or optimization technique out there also. Now, a summary of this particular, your lecture. Actually, with the development of computing technology, the new material discovery, using machine learning becomes a very hot topic for this material scientists, because as I already told you that uh, generally, if you see the material science people, they basically always go for the experimental kind of thing. But due to a lot of disadvantages in the field of the experiments, due to the more time consuming, due to the most experimental cost, right now, yeah, since last 3 4 years, a lot of researchers they are frequently using the concept of using some mathematical modeling concept in the field of material science and engineering or nanotechnology. And if you see this, as the research depends, it is showing that many advancing abilities such as low experimental cost, low time consuming, high generalizing ability, high density analysis, and currently it is used in basic chemistry, pharmaceutical science, and material science, such as prediction of melting temperature of a binary compound and the band gap energy of certain crystal. These are the small, certain example, but a lot of examples are there for development of new material, for your development of your nanomaterial, or to optimize the process parameter of a specific techniques which is used for development of a material or a nanomaterial. However, for this method has some disadvantages also. They have certain defect also. The accuracy of this result, it is completely depend upon the high quality of data and algorithm. Means if you not get a good amount of data, in that case it will be very tough for you to develop a good model. And if, even though you can develop a model, that model will not be it will not be give you a good result. For that high accuracy, data is very much necessary, and also you have to go for a development of a quality algorithms. And these defects, such as computing consumption, reliability of algorithm, and dependence of data must be overcome. And measures must be taken to improve this method, including this, establishing a reliability database, enhancing the combination of machine learning with other material theories, and exploring the new materials, research method, such as inverse design. Basically, in this field, in the application of this machine learning for the design or development of material, basically a lot of advantages are there, and sort of limitations are there. Limitation in terms of less exploration, because very less work has been done in this particular area. So whenever you will use that concept of machine learning, you need a good data. Other, until and unless you will not get the data, you will not be able to develop a good model. So that is basically a main drawback of this particular field. But right now, if you see, after 2 3 years, this technique will be frequently used in the field of machine learning, in the field of your this nanotechnology also. Okay. And your for the prediction of this this microstructure of a new material, or this composition and all, some papers are there. I mean, while preparation for this PPT, I was searching for the recently published paper related to that. I what I observe is maximum paper which has been published, that has been published in a high impact factor journal. The reason is that it has a very wide scope, first of all. Second thing is that very less work has been done in this particular area. That's why it has a very wide scope. Those who are doing research, they can choose this particular things, the application of machine learning, in the field of this your material science and engineering. That will be a considered to be a very good topic for the research. These are the references I have considered while preparation of this particular PPT. Thank you. If anyone is having any kind of question related to this, they are free to ask me. And then one thing I can tell you that basically, 2 3 years back, I was very much interested for experiment only. But right now, by seeing the recent development and all, I'm also shifted to this particular, I'm trying to learn a lot of techniques, and I'm applying that technique in the field of experiment, particularly in nanotechnology.